Hi everyone. So in previous video we discussed a recursion and memorization approach for the question minimum cost to climb stairs. Now in this video we will discuss the bottom up approach for this. So if you are not aware about these questions, then please refer the previous video. Here we will only talk about the bottom up approach. Now see what is going on. Initially we can start either from 15 or 20, 10 or 15, index 0 or either 1. How we reach this index? So what is the cost to reach index? Either we came from 15 or either we came from 10. So what is the cost? We will take minimum of 10 or 15, or from here in future if we make step we will add this cost as it is. So suppose if we are coming here, what is the cost to come here? Here it is 0. What we will take? Either the minimum of previous, minimum of this or minimum of this. What is the cost that we will took to reach this index? 20 plus 20 plus 10, 30. So it is 30. So what is the minimum of 15 or 30? So we will get 30. So how we generate our, let's understand this with another example. So here we will, this is our DP array, we will fill our DP array. Now at DP0 and DP1 these are the starting, we can either start from index 0 or index 1. So let me mark this as an index 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. And what is our idea? We need to reach this end, basically 10. So how we came here? Either what is the cost to came here? Either we will take this or this, minimum of this plus this to, if we need to jump in future. So 1 plus minimum of 1 and 100, 1, which is 2. Now what is the cost to came here? 1 plus minimum of both, minimum of 100 or 2, 2, we came 3. Now here what is the cost? 1 plus minimum of these two, previous index 2 or 3, 2, so it comes as 3. Now here what is cost? 100 plus minimum of previous 3 or 3, you can take any of them, 103. At this one, what is the cost of, what is the minimum cost? 1 plus either 103 or 3, we can 3, which is 4. Here what is cost? 1 plus minimum of 103 or 4, so we will take 4, 5. Here what is 100 plus minimum of 5 or 4, so we take 4, which is 104. What is here? Minimum 1 plus cost of minimum of 104 or 5, so we will consider 5, 6. What is the cost? Remember we need to reach the end of this. So what is the cost? Minimum of this or minimum of this? So minimum of 104 or 6, or minimum 6. And answer of this solution, this question, this example is 6, and this is our answer. So how we generalize this? So we can write cost of index is equal to cost of IDX current plus DP of plus minimum of DP of IDX minus 1 comma DP of IDX minus 2. And from this index we are starting I equal to 0 say I equal to n. Now for this index at the end, what is our answer? Minimum of this n or n minus 1. So what we will return at the end? We will return minimum of dp of n comma dp of n minus 1, not n, dp of n minus 1 or n minus 2, because these are the indexes n minus 1 and n minus 2. So this is our final answer. So this is the bottom up approach. So let's code this and first understand time complexity. Time complexity is as it is of n, because we iterate the whole array, and space complexity of n, because we creating one DP array. So this is our time complexity. But to understand this solution, you should know about the recursion and its memorization solution. Once you are you able to understand that, then this bottom up approach is just a piece of cake. So let's code this. Code for the bottom up approach. So we are writing bottom up approach for the same question. What we discussed, first we need a DP array. So we'll create a DP array, DP of size n and initialize with 0. Let's define n is equal to cost dot size. Now we know for DP of 0 we have already the cost we took is cost of 0, and DP of 1, because we say we can start from any index, so DP of 1 equals to. Now what we discuss, DP of DP of I equals to DP of cost of I plus DP of I minus 1 minimum of DP of I minus 1 comma DP of I minus 2. So this is our equation. Now let's write the for loop for this. For loop and I equals to, we'll start with 2 because we already covered 0 and 1, and I less than n and I plus plus. We copy this equation as it is. I will paste it. DP of I equal to cost of I plus minimum of cost of I minus 1. Now what we will return? We need DP of n. What is DP of n? DP of n is DP minimum of DP of n minus 1 comma DP of n minus 2. This is our minimum, so we will return this as it is. Now let's run this question. See, we pass all the test cases. Now let's submit it. Hopefully this solution will get accepted. Yeah, our solution got accepted. This is the crux of this solution. The steps is cost of I, cost is cost of current value of current index plus minimum of either minus 1 step or minus 2. What is the minimum? Because we will try to came here as low with by giving the cost as low as possible. And what is the time complexity? Same here, time complexity is of n, but here space complexity is also of n. This is only for DP array. For DP array, there is no recursive stack space is used, so we optimize it in respect to space complexity. So that's it guys. If you like the tutorial, please like and subscribe.